Hello, everyone. I just hope everyone got the joke here on deleting your server, getting rid of your server. So that was the idea. My name is Marcus Placona. I'm a developer evangelist for a company called Twilio. We're just upstairs. I don't know if you've been to a booth. If you've not, we're going to be upstairs. So just out of curiosity here, who doesn't know about Twilio? Like, who doesn't know what Twilio does? OK. So Twilio is a communications API that helps developers such as yourselves to add SMS messages or messaging such as IP chat, voice, like telephone calls, video, and any kind of like security, like two-factor authentication, into the applications you're already building using the languages you already know. Okay, so we have SDKs for obviously Android, we have SDKs for iOS, we have browser SDKs, and we also have a bunch of libraries for a bunch of different languages. But if you want to know more about Twilio, come upstairs, find me, and I can tell you everything there is to do with Twilio. I just want to let you know a little bit more about myself. So obviously, I'm Marcus Placona, as you can see there. Here's my Twitter information, so my Twitter account, GitHub. So some of the examples you're going to see today, and I'm hoping to do a live demo, okay, if the internet helps. Some of the examples you're going to see here today, they're going to be on my GitHub account. Also, I run AndroidThings.rocks. So I am an IoT enthusiast. So I run AndroidThings.rocks, which is an open source website with a bunch of like really cool Android things examples and articles. And I run AndroidSecurity.info, which is my other passion, just looking at security. So as you can probably guess, I am an Android developer myself. And what I'm going to describe here today is my journey into having backends for my applications. Okay. Now I want to tell you one thing. There was when I decided to sort of look into serverless and everything, I wanted to make sure I didn't do one thing on the back end. I didn't want to use JavaScript. And you will see this during my examples here. Nothing against JavaScript, just not my flavor. So today, I am here to talk to you about the new hotness that is serverless, but also what it is and what serverless actually means. Because I spoke to a bunch of people, and they were like, I don't really know what serverless is. So I want to talk to you about what serverless is, and I want to talk to you about what serverless looks like from a Kotlin developer perspective. So where should you go? How do you get started? What kind of things you need to do? Okay? So I thought that I would give you the formal introduction to serverless, in case you don't know what serverless is. And the formal introduction is, serverless architectures, they refer to applications that significantly depend on third-party services or on custom code that is run in ephemeral containers. Does that mean anything to anyone? Probably not. Yeah. So I saw this. This was written by a guy called Martin Fowler. So he writes a bunch of these like super interesting articles, which are boring sometimes. But this was written by Martin Fowler, and I was like, that doesn't make much sense to me. So I started to look a bit more. So I said, well, I said before, I'm an Android developer. So I started to look a bit more into like, OK, I need to find a way that describes serverless to me in a way I actually understand. And I found this amazing tweet, which very much describes it to me. So serverless, using someone else's Kubernetes cluster. And that's a great way to define it, OK? Because what you really do with serverless is, you don't need to have your own servers. You don't need to have your own like environments. You don't need to install things. The premise of serverless is no ops. Okay? So you don't need anyone, or you don't need to do it. You don't need to like spin up a server. You don't need to move on into like coming up with something like this, which is like this is a it's a Docker. It's like a Docker definition. So you don't need to do any of these things because someone else who's really good with ops has done it for you. Okay? So now your job as a developer is to develop the application, which is awesome because this is what I like to do. And this is one example of a Docker file, but it kind of goes all the way down. And in this example, what I'm using is I have a worker process, I have a Node.js application, I have a MongoDB, I have Redis, I have all these things, okay? And now, if I were to go this route, I would need to make sure all these things are up to date. I would need to make sure all these things are running sync. They're all communicating with each other. I have network. I have a volume with like database data. So now I need to think about all these things. Come on, I'm a developer. This is not the kind of thing I want to be thinking about. I want to be thinking about writing code and deploying and have it running, okay? Now, the other thing about serverless, so one of the other attributes of serverless is free. Not really. But most of serverless is free, okay? And I like to say serverless is free because I'm going to show you some more information about pricing here. But what you're going to find when you start to build serverless applications is most of your applications are going to stay within the free tier. I've known people who run businesses, like entire businesses, on serverless architecture, and they haven't paid any kind of bills yet. And this is not because they're being sneaky. They just haven't had to pay any kind of bills because they didn't reach the threshold of how much serverless actually costs. So I was looking at like, okay, so instead of just giving you like a bunch of examples of serverless and everything, I was looking at, okay, so how much does it actually cost? Like when if I start building something, what are the costs? So I found this really cool website which basically compares serverless providers. So you have AWS Lambda, you have Azure Functions, you have Google Cloud Functions, and you have IBM OpenWhisk, okay? In this example here, I have 1 million requests, okay? So I'm talking about making 1 million requests a month to a server. I'm talking about a 500 millisecond request, okay? So when you're thinking about serverless, it's really important that you think about really small and self-contained applications. So you're not building your entire application on this. You're building functionalities. And we're going to look at those functionalities as well. And I have a memory here of 128 meg, which depending on what you're doing, is totally fine. Now, what are the prices for this 1 million requests? So let's zoom in. 1 million requests, it's free. Okay? So 1 million requests is fine if you have an application that is, I don't know, in my examples, I'm going to use mobile apps as applications. And 1 million requests is totally fine because I don't have any mobile app that makes more than 1 million requests right now, any of my applications, okay? So I was like, cool, but there's going to be people in the audience that are going to say, well, yeah, but I have apps that actually make more than 1 million requests. And I'm happy for you. So as it turns out, it's very cheap. So when you go above those 1 million requests, it's very cheap. But let's look at how cheap it is. So I've changed my search here to 7 million requests. And 7 million is not just an arbitrary number. 7 million, I chose 7 million because it's above 5 million. Because most of these providers here, they let you go for free for up to 5 million requests. So I had to choose something that was really high. So I chose 7 million just because I want to see how much they charge. Okay? So when you get to 7 million requests, you're looking at still AWS Lambda, Azure Functions, Google Cloud Functions, and IBM OpenWhisk. IBM OpenWhisk is still under $1. Google Cloud Functions, $7. Azure Functions, $180. And the most expensive one, which is probably the one people are already using, which is AWS Lambda, $22. Still, under $25 for 7 million requests. So imagine like you have this machine somewhere doing computations for you 7 million times a month, and they charge you under $25, okay? Now, let me just make it clear to you. I don't work for any of these companies, okay? So I'm not trying to convince you to use any of these things. So this is purely my experience here. But I'll give you an example of how not using serverless can be very expensive, because I found this the hard way by just paying a big bill. So I had this scheduled task that ran every 10 minutes, okay? So I was like processing some text, I was processing some content, and it ran every 10 minutes. This scheduled task was running for 1 minute. Now, what this means is if I have a server, if I have my application running on a DigitalOcean account or something like, or if it's running like on Heroku or something like this, I am paying even though I'm not using, which means if I have an application that runs every 10 minutes, it means my server is idle for 9 minutes. Now, I'm still paying for those 9 minutes. Even though I'm not using anything, I am still paying for those 9 minutes. So the one thing that really got me interested when it comes to serverless is I only pay for what I use. So right now, I'm only paying for milliseconds or seconds that I use, or in this case, I'm only paying for 1 minute. I'm not paying for the other 9 minutes. I'm not paying for anything else that I'm not using. Because I'm not, with serverless, they're not really saving you any resources. It's like, well, I need to run this, so go and run it. But they're not really separating any resources for you. And I don't know about you, but like when it comes to having a scheduled task that runs every 10 minutes, it runs for a minute, and I'm idling or I'm paying for the other 9 minutes, I kind of felt a bit like this. I kind of felt a bit like, oh, okay, so like I'm not at this level yet. Like I'm not ready to say, hey, so I can spend all this money because like it's raining dollars for me. And I felt like, yeah, I'm actually throwing some money away by having servers that aren't doing anything. They're idling for such a long time and not doing anything, okay? So this is why I decided to look into serverless. But up until now, I haven't really talked about what serverless actually means with Kotlin. Like, what can you do with this and where can you go? So let's look at it. Let's look at what serverless and Kotlin means. Let's look at how to build an application using Kotlin. And let's look at what the major players are, okay? And I have to say the major players here are really three. Some of you will be familiar with this one and this one. So you have Google App Engine. We're not using Google Cloud Functions here because Google Cloud Functions only supports Node.js. Remember, I said I don't want to do JavaScript. I want to use Kotlin. So we're using Google App Engine here. This is Lambda, so this is Amazon Lambda. And the last one is one that you may not be aware of. This is IBM's OpenWhisk. And OpenWhisk, if you heard about this before, OpenWhisk is an open source project. So it runs on the IBM's infrastructure in this case. So it's running on IBM Bluemix. And it's the first one I'm going to look at. So it's the first one we're going to start by just looking at a demo. And I want to see like what is actually involved in building an application using IBM OpenWhisk. And I'm going to open my IDE here, and I'm going to hope that the internet will help out. So let's go into IntelliJ. Let's make this a bit smaller. And let's switch to a different project. Cool. So I have a project here, which is right now very empty. This is a Kotlin project, so doesn't have anything special to it. It's got one dependency, which is Kotlin, and nothing else. So the things I want to do with it is I want to have an Android application that makes a request to a serverless function. That serverless function just returns some data to it, okay? I'm not doing any processing here. I'm just making a request, and I just want to show you how I do it. I am going to start by importing JSON, and so I can return JSON, and I'm going to import Kotlin. Has anyone used Kotlin yet? Kotlin is awesome. So what Kotlin does is Kotlin is bindings, like Kotlin bindings for JSON. So instead of writing JSON on the Java way, you actually get to write JSON on the Kotlin way. Because one of the things I find a lot is I find a bunch of people saying, I'm moving to Kotlin, and I'm now writing Kotlin code. But the one mistake they make is they write Kotlin code that looks like Java. So they're basically writing Java code in Kotlin, okay? So such libraries like Kotlin, for example, they help you moving away from it. They help you out using the good things that Kotlin has. Now, I'm going to look at my main file here, which doesn't have anything, okay? So we're going to build this thing now. I'm going to start off by creating a function, a main function here. And I want this main function to receive and return a JSON object, okay? And we're going to create these JSON objects now. I want to pass a name to my function. So I want to pass a person's name to my function. And it will make more sense to you when we get to the Android side of things, when I show you the demo. So I'm going to create a variable here. I'm going to call this name. And this is going to read from args, which is just up here. It's going to read the name, and I want to turn that into a string. Cool. So really simple, right? You pass a name, like you make a post request to this. You pass a name, and I'm just putting these in a variable. Now I want to return some JSON out of it. So I'm going to return a JSON object. In this JSON object, I want to return a message from it. And I want to map it to what my message is going to be. And my message is going to be hello name. And obviously, I want to make sure I return this. OK? So that's it. OK? Now, the one thing you need to know for when you publish anything into a serverless container, when you use serverless, the one thing you need to know is you can't just publish your code. You need to publish a jar file. So we're going to turn this into a jar file. To turn code into a jar file, it's important that you... So if I say fat jars, does everyone know what fat jars are? Cool, I see some head shaking. So just real quick, fat jar is basically a jar that has all of the dependencies for your project. It's got everything on it, OK? So I'm going to go back to my Gradle file here, and I'm going to turn this into a fat jar, OK? So I'm just using, I just creates a new task called jar, and it compiles, and it gets everything and zips it into a jar file. Now, if I go into my terminal, I can go Gradle jar, and that's going to turn my application into a jar file. So if I say build successful here, it means I'm good, OK? So I have a jar file. So what do I do with this jar file? I want to publish it into, in this case, I'm using OpenWhisk. So I want to publish this into OpenWhisk. So I'm going to start with bx, wsk. So bx, Bluemix, wsk, which is OpenWhisk. And I'm going to create an action. So I'm going to go action create. And I'm going to use autocomplete here, because I don't want it to see all my typos. So let's call this KotlinConf. So this is the name of my function, OK? I want to be able to invoke this via KotlinConf. Cool. What am I doing here? I've got a name. I've got a namespace here, which I call demo. And I'm saying, go to my build, libs, OpenWhisk sample, blah, 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 jar, and get my jar file. The main here is like, this is the handler. So the main is main k, so it's my main file. Remember, I created a file that was called main.kt. So main.kt, sorry, main.kt. And I'm saying this runs on the web. Okay, so I want to be able to access this on the web. I want to be able to make HTTP requests to this thing. Now, this is where we need the internet. Hopefully it's going to work. Yeah, cool. So it creates the function. Now, how do I know this works? I can invoke this via terminal as well. So invoking this via terminal is bxwsk action invoke, and I'm just going to change this to KotlinConf. And I'm passing name. Remember, my application had a name parameter, and I'm passing name as Marcus. And what I expect is I'm going to make a request to this, and I want it to say hello, Marcus, to me. And yes, so I've got hello, Marcus. So I went to my serverless function. I made, this is one request, OK? Remember, we have 5 million to do. But this is one request. So I made my one request, and it says hello, Marcus. Now, where can we use this thing? You know, I said I was an Android developer. So I built this really simple Android application. Who's an Android developer here? Awesome. Who's an iOS developer? Cool, you can use that too. So I'm doing this with Android, but you can use that with iOS as well. I have an Android application here. I have a few imports I'm doing, so I'm just getting retrofit. If you're an Android developer, I know you will know about retrofit. I'm using RxJava in my application as well. Remember, I return JSON, so I want to be able to read JSON. I've got a logging at the bottom here because I want to show you my requests. and I'm using RX Android, so I can do all my nice bindings with RX Java. I have a service here. Again, this is totally related to retrofit. So I created a service here that I'm going to change the name of the function to be KotlinConf. I have a URL at the bottom here. So this is the URL for my Bluemix application. So this is the URL for my serverless function. And I'm not doing anything special here, so I'm creating a new service. I'm setting up the login so you can see all the login at the bottom. I'll clear what's in here. Choose this emulator here. And yeah, make sure it's clear. Cool. And that's very much it. So I'm not doing anything special. In my main activity, I have, and you'll be able to guess this, but in my main activity, I have an edit text. This edit text is where I can type in my name. Then I also have a button. So what I want to do is I want to be able to type my name, I want to click a button, and I want it to show that response to me on the screen. Okay? So we're going to go ahead and run this. We're going to run this in emulator. My emulator is looking a bit weird, so let me stop that and see if I can turn it on again. Okay. I don't know, so I downloaded this new emulator, so this is a Pixel 2, and sometimes it just it just looks a bit weird. So I'll try and start a new emulator here. I promise I tested this right before I came on stage and it was all good. So I'll just use a different emulator. So hopefully that's gonna work out. I just wanna be able to open this application in an Android device, and I wanna type in my name, and I wanna see that it makes a function request. Cool. So that's started now. I'll make sure I have the right emulator selected here, so you can see all the logs, and I'm gonna run that in my Nexus 5 device. And now it's going to do its thing. It's building the application and hopefully installs the APK. Yeah, so it's installing the APK. Cool, so it's launching the activity. So I have this activity. This is what it looks like, okay? Really, really simple activity. But again, I want to show you that you can call this thing from your Android or iOS application. Enter your name. I'm going to enter my name here. Press OK. Let me just close that so you can see the whole thing. And hopefully what's going to happen is, so keep an eye on here and keep an eye on the bottom here. So on the bottom you see all of the information about this request. So I'm going to go grip me. And so here's the information, and here is where it says hello. Okay? So really simple, but just imagine, I'm not doing any computation here, but just imagine I had something like a JPEG that I wanted to get resized, for example. Like the user takes a picture, and I want it to get resized, and I don't want to resize it in my app. I just want to take it elsewhere and use the computation power of something else as opposed to doing this in my app. And you'll be happy to know this works with other names as well. So it's not rigged just to my name. So yeah, we should see hello Jane there. So it's not rigged just to my name, and yeah, it's making the HTTP request. Okay, super simple example, but it shows you how easy it is. Let's now go back to the slides. Cool. So I showed you what I think is like the hello world demo here. Okay. But I want to look at some of the pros and cons of using what I just used, because I promised you I was going to look at different options, right? So pros and cons. Pros, it doesn't really care about what you're building. This is really important to me because I didn't have to change my code in any way to be able to deploy to OpenWhisk. I didn't have to write code in any special way to be able to deploy there. So it means that if OpenWhisk is not working out for me anymore, I can move providers. One thing you're going to find with serverless is there's a new provider coming up every week. So if it's not working out, I can just move providers. I can just get my jar file and literally just move it elsewhere. So obviously, with that, there's no vendor dependencies. Like you don't depend on this thing. Like you can move elsewhere and you're good. As long as you have your fat jar, you can just move that. Now, a con is the documentation are very fragmented. It's super fragmented. It's all over the place. Like, it's everywhere. Like, even these commands I just showed you, like the one to create a function, the one to invoke a function, they're not even in the same page. So the documentation is very fragmented, and sometimes it can be, when you don't know what you're doing, like when you're doing this for the first time, sometimes it just gets a bit annoying because you're like, yeah, like, this is not developer friendly. Remember, this is built by IBM. Oh, I hope no one works for IBM here. If you do, I love you guys. And this was pricing. It's free up to 5 million requests. Okay, I've not found anywhere that is free for me to make 5 million requests. And this is like, not only it's free for up to 5 million requests, but like when you go past it, you are talking about cents. You're talking about under $1 to get to 7 million requests. I'm sure that if you have an application that makes, I don't know, 20 million requests, you're making money out of it. So you're probably okay to pay, to have a bill of like $20, for example. Then I was like, cool, this is really cool. OpenWhisk is nice, but I am an Android developer and I want to like stay with Google. I want to look at like what Google can do. So I'm going to show you a demo for what Google can actually do. Now, on my demo, I decided to not do a live demo for this. I decided to record a video so you can see exactly what my first try was when I was trying to use App Engine. So, okay, so this is not Firebase Cloud Functions. This is Google App Engine. And my experience was very much like this. I have an application on the back end. On the background, I do Grado, build, and it goes, and it builds, and I see all that, and it says success, but then I scroll up, there's a bunch of errors, and I'm like, yeah. So this was my experience with using App Engine. Again, I know there's a bunch of people from Google here. No disrespect to anyone. And I'm going to tell you why my experience was like this. But I just wish I had filmed my own reaction when I saw this as well. I just wish I had my webcam on. Because it was very disheartening to do that. One thing that you should notice as well is I have a bunch of other things here. Like I'm actually adding dependencies for the App Engine, and I have dependencies for endpoints and everything. So I'm now changing my code so it runs on this. And when I try to run, it doesn't even run. Pros, if you're already on that platform, it's probably worth saying, yeah, I'm going to investigate this a little bit, and I'm going to try and make it work. The con is your code is actually locked to that platform because they don't accept a fat jar. They don't accept just you giving them your code. You actually need to give them a code that has more. Like you actually need to give them a code that is like dependent to that platform. Pricing is also different because like unlike the other ones, you actually pay per instance. Now you're paying to have an instance of Google App Engine running. So this is not a function as a service. This is a platform as a service, okay? And we go back, like if we circle back to my previous example, where we had a scheduled task that runs once every 10 minutes for 1 minute, you're paying. So my understanding is that you're paying for these other 9 minutes because you're actually hosting your thing. You're actually like, you actually have resources allocated to you. Now, one caveat is, this is an unfair comparison, okay? I wanted to use Google here, but this is an unfair comparison because I'm comparing a platform as a service to a function as a service. And because I can't write functions for Firebase Cloud, I had to use Google App Engine. So it's an unfair comparison because it's not the same products. But I really wanted this to work. I really wanted to say, yeah, no, this is great. Because like, I have all my stuff with Google, and I just wanted this to work. But now you're thinking, cool, let's move on to the next example. Let's move on to the Lambda example. And this is when story time comes up. I work at Twilio as a developer evangelist, and because I end up traveling a lot, when I'm not traveling, I like to work from home. I like to stay home. And I don't know about you, but I know many people who do this, but when I work from home, this is very much how I work. Okay? I have my headphones on, I'm coding, and I'm not hearing anything. I get into my home office, and this is how I'm working. Okay? Now what happens is, again, I live in England, so this is what the postmans actually look like in England, okay? So what happens is, my postman comes to my door, rings the doorbell, and I'm working like this. So what happens now? I don't hear my postman, okay? So my postman has a parcel, and obviously my postman can't really deliver that to me, and they just end up being very sad. So now I need to, at some point, I'll need to make some time to go to the depot and just get that parcel from there. And it's just this happens all the time, or it used to happen all the time, okay? Because then I realized that one of the things I always have in front of me when I'm headbanging like that is my phone. And contrary to what you're thinking, I didn't just give my phone number to the postman. What I did instead was I created a smart doorbell. So I changed my doorbell. I made some changes to my doorbell. And it's a shame because I couldn't bring my house here to show the doorbell to you. But I changed my doorbell. So now, when the postman actually rings my doorbell, I get a call. So my phone rings. And with my phone ringing, it's great because it's always in front of me. And I get that, I get that nice, that nice scare, oh, my phone's ringing, and it says there's somebody at the door, which is what I'm going to show you now. Okay? I'm going to go back to my IDE here. IDE, yes. And I'm going to show you this application I built, which is on my other IDE. So cool. So again, there's nothing very special about this, but this is an application I built using Amazon Lambda. Okay, I wanted to have an application that runs on every single one of these environments. So I built this one using Amazon Lambda. I don't have anything special here. I have Kotlin again. I'm using Spring Boot. If you're a Java developer, if what you build is backend applications, you will know about Spring Boot. Spring Boot works really well with Kotlin. They've been really pushing towards it. And I'm also using the Twilio SDK. Because remember, I want to make calls. I want my phone to ring when someone rings my doorbell. This is what I'm using. And I also have Mockito, because you need to do unit tests, right? Then I have my application here. Nothing special. So I'm basically just creating a Spring Boot application. So I'm just initializing this thing. There's nothing special here. And here is where all the magic happens. So I have a /call endpoint. This was my hello world. So this is the beginning of it, like a slash. So just so I knew that everything was wired up and working correctly. And I have a /doorbell endpoint here. So I want to go to a URL /doorbell, and I want to make sure my phone rings. And I want to rig that to my doorbell, so someone presses the button, my phone rings. So what I have here is I have the Twilio API. And it's not because I work at Twilio I'm actually showing you the API. I just wanted to show you that you can use external APIs here as well. So I'm using the Twilio API. I have a phone number, which is my phone number, so I'm just getting environment variables here. I have a from phone number, so this is where I'm going to call from. And I have a URI that I create. So this is basically how I tell Twilio how to talk to me. And it looks like this. Okay, so I have a pause because I'm going to pick this up, and then I'm going to hear a message saying there's somebody at the door. So this is what I need. Then I create the call. That's it. Now, from my doorbell, again, I'm gonna need you to be creative here, okay? I'm gonna need to use your imagination because, like I said, I would have preferred to bring my house and my doorbell so you could see it, but because I couldn't do that, I did the next best thing, which is, as a developer, I just built a really quick app that has a ring button here. So imagine this is my doorbell, okay? This is not impossible. So the way I built my doorbell is with Android Things. And Android Things does exactly that for you. So I have my application here. In my application, I don't have anything special. Like I have retrofits again. I'm using RxJava. So I'm using the normal things here. And I have a service which I create. And in that service, I just make a request to my application, to my serverless function. Okay, that's it. Not doing anything special here. I just kind of have a fancy name for my serverless function, but that's it. In my main activity, this works pretty much the same way as the other one. In my main activity, I have a button, which is the ring button, and when someone clicks on it, I want a ring doorbell. And what ring doorbell does is, it makes a request to my serverless function. Now, this is the one I'm worried about, because I'm going to try to run this, and we'll see what happens. So I am on the right. I'm on the right device here, and when I run that in the I did that again. Oh, I think it's good. Oh yeah, no, it's good. Yeah, cool, awesome. So again, use your imagination. Imagine this is the postman coming in. That's my doorbell. Postman comes in, and I'm gonna put my ringer up so you can see that my phone rings. So the postman comes in and presses ring, and hopefully my phone is gonna ring. Ring. Oh, so phone's ringing. I'm gonna bring this closer to my microphone here so you can hear it. Could you hear that? Sorry. Well, it says there's somebody at the door, okay? Obviously, when you're at home and you get that, you'll be able to hear that. So this is the application I built, okay? And I built this application totally out of needs. Like, I needed to have a way for my mailman to get to me, so I wouldn't miss any of my parcels. Back to the slides. Now, I want to leave some time for questions as well, but I'll just kind of talk about the pros and cons of this thing. So Lambda, a lot of people already use AWS. I was actually talking to someone here today who says, well, I have been using AWS for a while now, so for me it makes sense to just stay there. You know, I had the same idea with Google and it didn't work out. But it's easy to troubleshoot, okay? Like if you have any issues, if you have any problems with your environment, it's very easy to just go and ask. Like, I just go to Stack Overflow and ask the question. There's like a bunch of people answering it. You have no vendor dependencies as well. Like, I didn't have to change my code for this to work. Now, if I were to get this and deploy to a different vendor, it would still work. It's the same code. Comprehensive API console. This is very nice, actually, because even though you can't really invoke Lambdas directly via HTTP, they have this thing which is the API console. And the API console lets you like organize all of your endpoints. And you can basically map the endpoints. You can say, OK, /co goes to this Lambda function. /message goes to a different Lambda function. So you can basically build your API using this. So no vendor dependencies, comprehensive API console. Cons are the docs, again, they're a bit all over the place. As a developer, I find that every single time I use something from Amazon, I have this same experience, okay? The docs are like, they're not amazing. Like, they're all over the place. I see people shaking heads, and they're all over the place. And again, when you're learning something, it's a bit hard when the docs are not there for you. But then again, it's easy to troubleshoot because there's a good community behind it. The free tier is not as generous, okay? We talked about 5 million requests before. Their free tier is basically 1 million requests. If you go to anything above 5 million requests, you're going to pay something like $20 for this. So it's not as generous. And yes, you can't really invoke Lambdas directly via HTTP, so you can't make those requests. Pricing, again, free up to 1 million requests a month. But I kind of want to finish this up by saying, and this is something I only realized when I started to use serverless quite a lot. I kind of want to finish this up by saying, serverless is not the future, okay? Because serverless is happening now. Like, you're not going to start using serverless in 5 years' time. Serverless is actually happening now. There's a bunch of people using serverless. I was talking to Expedia upstairs, so I was talking to some of the sponsors upstairs, and they were telling me they're making, I think it's something ridiculous, like it's 1.3 billion requests a month on serverless functions. So it's like a lot. Like people are actually using this for real in production. Like, you're talking 1.3 billion requests, and that's crazy for me. With that, I have been Marcus Placona. Here's my information. If you want to chat to me, or if you want to find me, or if you want to ask me any questions, or if you want to talk about Android, or Twilio, or serverless, I'd be more than happy to talk to you. Thank you very much. Yeah, ask the questions and I'll repeat, because I don't think we have microphones. So do you want to?
On these serverless, on these things, you can't store data, can you?
Okay.
Upload images.
So the question is, on serverless, can you store data on serverless? You can. So there's going to be a database with all of these providers. Is going to be database. The only one thing you can't do is you can't keep state. So you can't say, I'm going to make a request now, and then I'm going to make a request later, and they can be connected. But in terms of like storing data, you can. In terms of storing images, you can. So you can do all these things. All of them have different places where you can store. So like, you know, Amazon will have S3, for example, so you can use S3. Are there any security or privacy risks when using these services? Yes, there's no security. Like, people can just make requests. Well, people can just make requests to it if you don't have. There's in each one of these things, when you create a function, you can add authentication to your functions. There's next to no documentation to this, but I was thinking about the same thing, because I was like, I only want my Android application to be able to access these functions. I don't want anyone else to do it, because I don't want anyone else to make my bill high by just making thousands of requests. So there's no documentation for this, but there are ways you can add security to them. One nice feature you have with especially AWS Lambda is when you use the API console, you can add authentication there, and it's nicer, because you're not adding authentication to each one of the functions, you add the authentication to your API. So yes and no, because it's not very easy to do, but it's possible. Cool. So the question is, as a JVM language, usually the startup time is low, because so they call this thing cold start, okay? Because it takes a while to start. And which one is the best provider? I tested the 3 of them, and I found that IBM OpenWhisk was like by far the fastest one. It's almost like it's always running, okay? I can call a function I created like 3 days ago, and it's almost like it's always running. Amazon Lambda, not so much. Amazon Lambda, so on the first time you call it, if you have a function that has been running for a while, on the first time you call it, there's going to be like a 2-second delay, which I think is a lot when you, especially like on a mobile phone. 2-second delay is quite a lot. So the code starts on Lambda is higher than on OpenWhisk, for example. There was another question here. Yeah. Okay, so the prices is per operation. And the question was, is there any limitations on what you can do in those operations? Can you like transcode a video, for example? Yes, but what's going to happen is, you're going to use more memory. Like transcoding a video, for example, you won't be able to do it with 128 meg. You're probably going to have to increase, and as you increase memory, the prices go up. But there are no limitations to what you can do. So there's timeouts on this. You can configure timeouts as well. So when you deploy your Lambda function, you can configure timeouts for it. But I had functions running for like a minute, for example, and it's so good. I haven't tried to transcode videos, but I know a bunch of people. I was actually talking to someone not too long ago. I was talking to someone. It was either like Pluralsight or something, and they do it exactly like this. So people just go up. I was actually talking to you. Yeah. So that guy there, he does it. So yeah, it's totally doable. Yeah, it's totally doable.
How do you separate production and development data?
So question is, how do you separate production and development data? If you're using something like OpenWhisk, for example, you can run, because OpenWhisk is open source, you can run it locally, so you can run the whole thing locally, and then when you're ready, you just add a BX in front of it, and then you have your stuff in production. So with OpenWhisk, it's easy. With Amazon, because you can't really run Amazon locally, you're going to end up having to create, like, if you're talking about like images, for example, you're going to have to end up creating a bucket for your test images and a bucket for your production images. I think we're out of time now. I'm going to be upstairs. I'm going to be outside. I'm going to be upstairs as well. If you have any questions, please just come and ask me. Thank you.